Welcome everyone tonight to tonight's Twin Cities .NET User Group meetup. Our speaker tonight is Matthew Hess, and he's going to be speaking with us about Much Ado About Nullable C# Nullable Reference Types Explained. Matthew Hess is a Microsoft MVP and software engineer with CG Infinity and the organizer of the Albuquerque .NET Users Group. Matthew got his start programming using Borland's Delphi and has been working with C# since version 2. Matthew has written software for many different industries, from legal to financial services to biotechnology to nonprofit. His YouTube channel, at C# Artisan, is meant to help programmers of all levels become better at the craft of programming in C#. And with that, Matthew, I will let you take it away.
Thank you very much, William. It's great to be back with you guys. Really excited. I recognize some faces and names. Some of you all are new. And, I want to just begin by talking a little about my process. Like, how do I come up with a weird topic like this? Where does this come from? Because, I'm not Charles Petzold. I'm not Marcus Egger. I'm not like one of these super luminaries. I'm just a regular programmer who bumps into stuff. And what I've learned is that when something is bothering me, or when I'm avoiding something, or it's irritating me, sometimes that means I should stop and actually look more closely at it. Treat that as like a compass, like a navigation beacon. Like, why is this thing bugging me so much? Or what's going on here? Because it's often an indicator that I don't understand it, actually. So that's kind of what happened with nullable reference types. They were just sort of bugging me, and I was kind of just ignoring them and hoping they might go away, or I don't know what. I was in denial. And then one day I was like, okay, Matthew, enough of that. Do what you're supposed to do, which is take a deep dive, look at it, try to understand what's going on here. And it set me on a very interesting kind of personal discovery journey. And so that's what I want to take you all through, because I was surprised. I had some misconceptions. And so that's what we're going to do today. I'm going to kind of take you on my journey of figuring these things out. And we'll provide some analysis and critique at the end, and then leave you kind of with the question of like how you're going to decide if and when to use them. But for starters, has anyone else been mildly irritated, confused, resistant to this language feature? William, I think you said it had bothered you. Are there other people who kind of are like, we're unsure of it about it?
Yeah, you're spot on. We had talked about this. I said, I hope you can make me a convert, Matthew.
Well, I'm not going to try. Okay, I will try to explain it, then you can decide what you're going to do. But okay, anyway, I feel like a lot of us have had this reaction. And if, you go into a group of experienced C# programmers, you're going to get a really wide range of opinions on this one. So with that, I've got some slides to kind of structure things. Let me start my slideshow probably from the beginning. Why don't we do that for a change? Let's start from the beginning of the slides instead of the end. What do you say? All right, so much ado about nullable. We're going to talk about nullable reference types. And again, I'm Matthew Hess. And I'm going to dedicate this to my father, Lawrence Hess, who passed away last summer. I really lucked out in the dad department. Daddy, I miss you a lot. And I am constantly aware of everything you did for me to help me have the life I'm having. So thank you, Lawrence Hess. I also want to acknowledge CG Infinity. I'm here in the CG Infinity offices. It's a good place to work. It's a very enlightened organization that kind of actually walks the talk on a lot of the values. And they do sponsor the Albuquerque .NET User Group. So thank you, CG Infinity. So over the years, as William mentioned, I've been doing C# for a bit. And over the years, if any of you have also been kind of growing along with this language, you'll know that C# has evolved a lot. And every couple of versions, they add these amazing new features.
Yeah,
For example, we
Matthew,
can even, Yes, sir.
Matthew, we do not see a screen yet.
Oh my goodness. Am I not even sharing? Okay. So that's the problem here. Thank you for calling that out before we got 30 minutes in. That was kind of would have been sad. All right. Um,
Yeah,
I'll show
credit goes to Dimitri. There you go. Now we can see it.
yeah. Okay, that was my title slide. It's pretty. You like it? Title slide. Um, there's my dad, and there's the CG Infinity logo. Those are my acknowledgments. And then this is the slide I had just landed on. So, generics were not even in the original language spec. And then we got object and collection initializers in C#3, and we got named and optional function arguments, which we all take for granted in C#4. Of course, async await, another one of my favorite topics, was introduced in C#5. And then, in subsequent versions, all of these things that we use daily, extension methods, right? There wasn't link at the beginning. Tasks, lambda expressions, anonymous types, auto properties, tuples, pattern matching switch expressions, all of this stuff. And I would say that people are pretty happy about it, right? All of these features have made the language better. And people are like, yeah, great, I can use that. Not a lot of things where you're like, why did you do that? There's some niche features for sure. But overall, the language has evolved in a really positive way. And then in C#8 in 2019, they dropped this thing on us, nullable reference types. And in comparison to all these other cool features, like I said before, a lot of folks are like, wait, what? What the heck? So what I want to begin with is asking the question, like, why? Why did Microsoft do this? What purpose does it serve? And it's really very simple. The purpose of this language feature is to help prevent null reference exceptions. Okay, so null reference exceptions. That's something you may, that's a buzzword you may or may not use a lot, but let's just review and unpack that. So what is a null reference exception? So here's a bit of code. I've got this polygon class, which has a sides property, and it's got this static function called hello triangle, which accepts a polygon and then says, well, if that polygon has 3 sides, we're going to say it's a triangle. So this line of code right here, if p.sides equals 3, that's not safe. The problem with it is that p, this polygon type here, it could be null. And if it turns out that p is null, this is going to blow up at runtime. And you're going to get system.null reference exception. Object reference not set to an instance of an object. P was null. So that probably has refreshed your memory. You're like, oh yeah, right. Null references, like invalid pointers. I get this. So here, this goes back to the origins of C#. We've always had this issue. And most programmers learn some basic techniques to prevent them. So for example, here is a way you could have rewritten that function. So by putting a guard on, if p is not null and p.sides equals 3, then say it's a triangle. So C# Booleans are short circuiting, which means if p is null, it's not going to evaluate the right side. So this is perfectly safe. You just have a guard condition. You check for your nulls, and now your code is null safe. This is kind of a newer syntax using null conditional. If p question mark dot sides equals 3, that works also because this null conditional operator, the question mark right here, says only evaluate what comes after the dot, only dereference it if it's not null. Excuse me. So that's the basic technique, right? You check for null before dereferencing, before using the variable. We all learn how to do this. So here's an example with strings. In that case, I was using an object, polygon, but strings are also reference types. They're pointers, basically. They have some special implementation and special behaviors that make them feel and work a little bit like value types in certain ways, but they can be null. A string type in C# classically just can be null. So here's a function called replace ampersands, and it takes a string. And this isn't safe, right? If we just say return s dot replace, replace the ampersand with the word and, well, what happens if s is null? If s is null, this is going to create the same null reference exception. And here again are two alternatives for guarding it. So if string dot is null or empty s, then just return an empty string. Otherwise, do the replace operation. So we put a guard on, or again, using null conditional and null coalescing, we could say if s dot replace and then coalesce it to string dot empty if this was null. So far, so good, right? That's what they are, and that's how we normally handle them. So the question is, wouldn't it be nice, the thought, right? The thought experiment. Wouldn't it be nice if the C# compiler could help us out? What if the C# compiler could say, look, this is a problem. You might want to look at this one, maybe give us a warning at least, and say, this is possibly not safe. Take a look at it. And we have compiler warnings all over the place. So how is this done? This is done using what is called static flow analysis, which is basically analyzing the code without compiling and running it, right? It's static. So the static flow analysis reads through your code and it understands a lot about your code and it can flag things. So for example, if you were to write this line of code, int x, you would see you'd get the little squiggly underneath it. And then down in the warnings, you would get CS0168, the variable x is declared but never used. We see these kinds of warnings all the time. That's just static flow analysis showing us something that we might want to take a look at. So wouldn't it be nice if the compiler could do this kind of thing? And by the way, I'm sure you can think of other ones, right? Not just variable is declared but never used, but there's dozens of these that we run into fairly frequently. So wouldn't it be great if the C# compiler could do this kind of thing for us with regard to possible null reference exceptions, code that's not null safe? So here's the challenge with that. Here's kind of the fly in the ointment. And it's that these reference types, or these variables that point to a reference type, they kind of come in two flavors. Now, this is my terminology. You're not going to go find this in some textbook. So one flavor is the could be null variable, where it legitimately could be null. And then the other is it will never be null. It's just not going to be null. The code really doesn't allow for it to be null. And so let's take a look at these, some examples. So this first one, if we say polygon P equals shapes.find and look for an octagon. Now, this next line isn't safe because if your shapes collection does not have an octagon in it, then polygon P will be null. So this is a case where, yeah, it very well could be null. And therefore, this is really not safe, and we would like a warning. However, here, polygon P equals new, give it sides 3, this polygon will always be instantiated. Right? This is perfectly safe than to say int I equals P dot sides plus 1. Perfectly safe. There is no situation where P is going to become null after this semicolon and before this line of code. So this is the second flavor. An example with strings. So string s equals SQL data rater dot get string sub 0. Okay, that's fine, except that could be a null string. So then if we do s equals s dot to upper, we might have a problem. That's not safe. But the string.concat function always returns an empty string. It actually never returns null. So string s equals string.concat hello null is fine, right? This s here, at this point, s is guaranteed to not be null. So we would like compiler warnings on the could be null ones. We really don't want compiler warnings on the will never be null ones. The part of this that's kind of a mystery to me is it still doesn't seem like that deep of a problem, but apparently this is. Apparently this is hard. And so originally, when the Microsoft team first put this all together, they made the decision that it was up to the programmer. We're not going to try to warn you on this. We're not going to try to guess your intentions. It's up to you. This is programming. Put on your big boy pants. We're going to garbage collect your memory leaks, but you're still going to have to guard your variables and check for null. So basically, it was just left to the programmers to write defensive code. So with null reference types, they kind of changed the stance here and are like, okay, we're actually going to try to provide some compiler assistance. And in order to solve this ambiguity between could be null and will never be null, we're going to give you a tool called annotations. And we're going to tell you, you can use a question mark suffix to mark a variable and tell the compiler that it could be null. If you don't put the question mark on there, the compiler is going to assume that it's should never be null. And if you do put it on there, the compiler is going to assume that what you mean to say is that it could be null. So here is an example of a will never be null variable. Polygon P equals new. And notice the polygon is not decorated. There's no suffix. Here's an example of a could be null variable. Polygon question mark P equals shapes.find, look for my octagon. And then here's the example with the string. String S should never be null equals string.concat. String question mark S equals SQL data reader dot get string. So this one might return null. So that's what the little question mark does. It doesn't actually change the type, and we're going to talk about that more. This is one of the most confusing and kind of counterintuitive things about this feature. It really doesn't actually change the type. A polygon is still a polygon. String is still a string. It's just that you've added this annotation on there that allows the compiler to make better guesses about your intent and what it should be possibly warning you about. So once you've annotated your code in this way, now the compiler can analyze the code. So you're only going to get warnings where you want them. So this one, you don't get a compiler warning, int I equals p dot sides plus 1, because you've said, no, polygon P should never be null. And here you would get a compiler warning because you said, yep, P might be null. Similarly, you would not get a compiler warning here. S equals S dot replace. You would get one here on S equals S dot replace. The difference here, we've said, no, this one might be null, and this one we've said it's not going to be null. So this really is the secret sauce that makes this entire thing work. And I'm just going to pause there for a second because it's quite possible that everything I've said just came completely out of left field, and this is brand new to you. Like you've been using the feature, but you hadn't thought of it in these terms. So I just want to take a minute, let it sink in, and open it up for just a few comments or questions before we kind of start unpacking the implications of all of this. Any thoughts so far?
No thoughts so far. Checking the chat. No.
Are people, are we getting
with
some
you so
nods
far.
of like, okay, that kind of makes sense? Well, hopefully. Because I'm just on the one screen, I don't see people's faces right now. So,
Yeah, we turned off everybody's cameras, Matthew.
okay, okay.
It was interesting how you said that the polygon nullable, the question mark at the end, really is saying that this could be null. I've always read that as kind of a different phrasing, like this will be nullable at some point in the future, and I need to I need to handle it and call, has value or whatever that method is. So I'm with you. That was a different take on it when you said that.
Yeah.
So that made me kind of look at it and question myself a little bit more, which is what I'm here for. So yeah,
Yeah, so that was great because there is no p dot has value. You just pointed to my next slide, which is these are not the same as nullable value types. So what you just described, the whole like dot has value, dot value construct, that's how you do nullable value types. And that isn't actually in play for nullable reference types. This is one of the most confusing parts to this. So I'm so glad you brought that up. Perfect segue. So let's talk about this, how these are not the same. They're superficially the same because they're named the same, but they're not the same as nullable value types. So let me explain what I mean. So on the left here, we have a class, my class, and I have public int normal int, public int question mark nullable int, right? So this is our nullable T shorthand for an integer which could possibly have a null value. So this is a nullable value type right there. And then I have public string normal string and public string question mark nullable string. And these look symmetrical, right? They look like a mirror image of each other, that normal int is to normal string as nullable int is to nullable string. And I'm sorry, that is not true. And here's how we can prove it. So if we do a little reflection, so field info equals type of my class dot get fields, and then loop the field info and write out the field name and the data type. Oops. So what is the output of writing out the name and the data type for these four fields? So the data type of normal int is an int32. The data type of a nullable bool, it should be int. That's a typo. The data type for nullable int is the generic nullable tick one. Okay, it's this generic nullable kind of struct. The data type for your normal string is string, and the data type for your nullable string is string. It's not a generic nullable string thing. It does not actually change the data type. That string and string with a question mark are the same, whereas int and int with a question mark are not the same. So this is kind of shocking, right? It's like they went to all this trouble to use the same syntax and the same naming in order to try to leverage like the same conceptual framework in your brain, but it's kind of a mirage because they're not the same. So if they're not the same, what are they? Like, what is that question mark actually doing if it's not changing the data type? So it's basically adding a custom attribute. Oops. Okay, it's adding a custom attribute. Wait, sorry, just one moment. Well, the custodian is checking the offices. That's all right. I'll live with the lights. I'll be brave. I can live with it. So, okay, so it's adding this custom attribute. So how do we know that? So here's something where we're going to say this variable attribute is field.getCustomAttributes.first or default, where the name ends with compiler services nullable attribute. That's just a way to fish this thing out of the metadata associated with the class. So then I'll do the same code, which is get the field info, loop it, and write out the flags value associated with this attribute. It's a byte flags. And you can see that the normal string has type string and the nullable attribute flags value of 1. And the nullable string has type string and a nullable attribute flags value of 2. So that's all it's doing. It's like putting this little bit flag in the metadata for the type. And with that in hand, the C# compiler can work its magic. So this is everything. We've all worked with attributes all the time, right? Has anyone ever done, like entity framework or JSON serialization or written an ASP.NET controller, right? We're always decorating methods and types, or Azure Functions use them all over the place. So attributes are used, sorry, attributes are used to add metadata to your types and your functions and your fields and other things. And then there has to be a target that's going to consume it, some framework or platform. So when you decorate your controller classes as controller with the paths and other things, what uses that? Well, when you start up an ASP.NET service, it uses reflection and it goes through your code and it picks out all your controllers and it wires up all the routing. That's what it's doing at startup, is it's using reflection to figure this stuff out. Or Entity Framework does the same thing. When Entity Framework kind of starts up, it reads through your code through the metadata using reflection, and it wires up all of this kind of runtime in the background. So the only thing on earth that I know that consumes this little attribute is the C# compiler. It exists just for the C# compiler. Nothing else is gonna pay attention to it, as far as I know. So a custom attribute, again, just to emphasize this is not real, right? This is fake code that I wrote just to kind of illustrate the point. But you could define a custom attribute class. So public sealed class might be nullable attribute, which is an attribute, which targets fields and parameters, is not inherited, and doesn't allow multiples. And then I could use it. And so I could say here, public static void hello triangle, and I could say that polygon P might be null. Now I've annotated it, right? I put the attribute on there, I added some metadata, and in theory, a framework or something could say, oh, look, polygon P might be null. I'm going to do whatever I do with that information. So this is kind of a more literate way of doing this, right? It just is more explicit. But this is really what polygon $P is doing. So it adds this custom attribute. Okay, so that's what it is. That's the why. Why does it exist? To help us prevent nullable reference exceptions. And the way it wants to do this is by allowing the compiler to give us better warnings. And the way it's implemented is you, the programmer, decorate your class, you annotate your types with question marks to tell the compiler which ones to worry about and which ones not to worry about. That's how the feature works. So the next section is getting into practical advice about implementing it. But again, let me pause real briefly. That was theory, kind of high level, right before we pivot into turning it on and seeing what it does, practically speaking. Any questions? All right, I'm going to keep forging ahead then. So what do we do? How do we implement this feature? So the feature itself is turned on at the project level using this nullable attribute in the property group. This is in the csproj file. And by default, it's enabled. So when you create a new C# project, it'll be enabled. And some of us, the very first thing we do is we go in here and we turn it off because it bothers us. But that's because some of us are old and grumpy, like me. So you can turn it on or off at the project level. As you're going to see, there are ways to control it at a file level, and we're going to get into that a little bit. But if you just go into your code and you turn this on, you're going to start seeing a set of warnings. And there's not an infinite list. And so I just have basically cataloged here the main nullable, possible null reference compiler warnings that you're likely to see. And I've given examples of what would cause them and how you would address them. So for example, here we have string s, a nullable string, s1 equals null. And then we say int I equals s1 dot length. So this right here will generate a CS8601 warning, which is the dereference of a possibly null reference. That is your classic, you would have a null reference type exception right there. That's the main classic exception that it's trying to prevent. So it warns you. And a way to fix it is to just say S1 question mark dot length. So using this null conditional kind of syntax. Here's another example: polygon p equals null, int I equals p dot sides. And again, guarding it here by saying p question mark dot sides. That's safe. So that will only dereference length and sides if the variable on the left is not null. The next one is that's probably the single most important and common one. 8600 is converting a null literal or possible null value to a non-nullable type. So this is kind of a narrowing conversion type problem. So string nullable s equals null, and then string not nullable, regular string, s2 equals s1. We're assigning a nullable string to a non-nullable string. This is like a narrowing conversion. And so you would get the CS8600 warning. And if you use our null coalescing double question mark, then you can make it safe. Here again, polygon P1 equals null, P2 equals P1 is a problem, P3 equals P1 or new, right? Basically, whichever one is not null, that's safe, and that'll suppress CS8600. CS8603, a possible null reference return. So getName is a function, and it's supposed to return a string, not a nullable string. So we're going to, maybe what we would do is look up some record by ID and return the name. If no record is found, if we return null out of this function, we'll get a CS8603 warning that this function advertises, I return non-nullable strings, but you are possibly returning a null. So that's a warning. And returning the empty string would be the safe alternative. And here's another variant. GetShape is supposed to return polygon object. And let's just say that there's a collection of shapes, and we're going to go look for one with that number of sides. And if one isn't found, well, this is tricky. What do we do if we return null? That's a warning. So we could do something like return could instantiate a new one with that number of sides. That maybe changes the business logic a little. So it's sort of an interesting question, but it will stop the compiler warning. So those are three really common ones. There aren't that many. CS8604 is possible null reference argument. So here's a function, print the length of a string, and it takes a non-nullable string, and it says debug.print s.length.toString. Now, if we say string with a question mark, maybe null equals null, and then we pass that to print string length, that's going to give us a warning, because print string length expects a non-nullable string, and we are passing it a nullable string. And then here's, again, a version of it with the polygon, sort of the same symmetrical problem. So there are different ways to do this, but probably the best is to just modify the function, not the caller of the function. So in this case, we could say, all right, print string length will accept null strings. It doesn't have to be so strict about its input. And then inside of it, we'll make it null safe. So it will check if the input value is null and do the right thing. So this makes it function a little bit like string.concat, which accepts nulls and handles them. Again, print polysides saying if you pass me a null, I can do that. You know, I will just check to make sure that we actually have a polygon before I print out those sides. Otherwise, I'll give you the empty string. So this is a nice, nice way to handle certain ones is actually to revisit the function here rather than the calling code. There could be, it just depends. You may or may not control both sides of this. But you have that option. CS8618, a non-nullable field or property is uninitialized. This is probably the most common one that people bump into, because if you're creating these like simple POCO classes or DTOs, right? These data model classes, which just have public get init or get set fields for the purpose usually of JSON serialization, right? And just basic data modeling. What happens is when you declare something as a string and you don't initialize it, you get a CS8618 warning. And so the trick is just always initialize your string properties to the empty string. That will shut up that warning. Similarly, if you have a non-nullable polygon or some object, you can always initialize it. And that way you won't have a null warning on that one. This is probably the most common little code change that I end up making, is going all through my DTOs or my model classes and adding defaults for strings, for string properties. So starting in C#11, you can also use the required keyboard, which is something that's really interesting. Do you need me to move for a little bit, or are you okay? Do you need me to move, or no? It's okay. All right. All right. So the required keyboard or keyword is something you can put on a field or property declaration. And what it does is it makes it so that the compiler checks and ensures that when your object exits the constructor, that you have given that property a value. So person P1 equals new, name equals Fred. That'll work because right here, as it exits the constructor, on that semicolon, name has a value. Or person P2 equals name equals blank. That's fine. But person P3, name equals null. This will give you a compiler warning. So this is kind of a cool feature that you can use also to deal with guaranteeing that these get initialized. Now, again, if this is in a framework like ASP.NET and the object instantiation and deserialization and serialization is all happening automatically for you, then this isn't going to work, because you aren't necessarily going to be in a position to write the constructor code. So you'll have to do something like this. Second to last one is 8625 cannot convert a null literal to a non-nullable reference type. So we have this function, do something, which takes a string, does whatever. So if we say do something and we pass it null, that generates a compiler warning. If we say, and here's a function called do something else, which takes a polygon, do something else, passing in null also generates this warning. And in this case, we can just solve it by annotating the variable, right? So void do something. We say this function can accept. Basically, we're modifying the function, not the caller. We can tell it, yep, this one takes nullable strings and this one takes nullable polygons. Now we have a bonus warning. I went to all these lengths to tell you how nullable reference types and nullable value types are different, but turning on this feature, enabling it, actually enables a nullable value type warning that is not turned on otherwise, which is very amusing to me. So if you were to write this code, int I equals null, and then so nullable int I, and then int j equals I dot value, this will suddenly start giving you a CS8629 warning because this is a possible null reference exception at runtime. But you only get this warning if you turn on nullable reference types, even though it's a nullable value type related warning. So you enable it and you get all of these warnings. Now, one small but important detail to cover when we talk about implementation is the null forgiving operator. So the point of the null forgiving operator basically is there may be scenarios where you have a variable that is formally nullable. It's got the question mark on it. But you know, practically speaking, because you have higher order knowledge of how the program works, that even though it's declared as nullable, it will never be null in a certain context. And rather than change the variable itself, which might be nullable for some other good reason, you can kind of suppress the warning locally using the null forgiving operator. So here's an example. So I have some class, I've got my program, and I've got this polygon variable here, which is nullable. And that when my program runs, it does init poly and then use poly. Sorry. So init poly instantiates the polygon, and use poly does something with the polygon. And I have this higher order knowledge that use poly is never called before init poly, which means that poly right here, underscore poly, even though it is formally nullable, I know that it's not going to be null at this point in my code. And so the CS8602 is kind of a false warning. But the compiler can't know that, but I know that. So I can just say poly bang dot sides. And that is essentially like using a pragma to suppress the warning around this line. Right? You could turn the warning off and turn the warning on. It would be very verbose. The exclamation point does the same thing. So it just suppresses it locally. Use sparingly as a last resort. I did have a project once where once I discovered this, I just started putting these things in everywhere. I was like, oh yeah, bang, 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 bang. Look at all the warnings. They're all going away. Shoot them down. And then I realized this is a really bad idea, right? Because it's basically the worst of both worlds. So there are situations where you might need to use this. They gave it to us, but I would not lean on it as your first tool. So the next thing to talk about is approaching the problem of updating an existing project. And I'm going to suggest you have 3 methods for how you might approach an existing project. 1, I call bombs away. 2, file by file. And 3, annotations first. So with bombs away, you take your existing code base, the one that was written before this feature existed, and you just enable it and see what happens. And depending on the size and style of your project, you might have hundreds or thousands of compiler warnings that pop up. And then you just roll up your sleeves and you start trying to cope with them. So I do not recommend this approach for anything but the smallest code bases because first of all, it's no fun at all. But also it might make you make some dubious choices. You might not necessarily address the warnings in the correct way because you might just fall into like, I'm going to do anything I can just to clear these and shut them up. And when done right, this feature should force you to do a little thinking. And when you're overwhelmed with thousands of warnings, you might just go into autopilot and start trying to suppress. So you can do it, and I'm sure some of us have, but I don't recommend it. So another slightly more controlled approach is just to go file by file. So disable it at the project level. And then in each file you want to treat, you can actually turn on nullable enable annotations and nullable enable warnings. These two pragmas in a file has the effect of just saying enable for a single file. So then at least the scope of your work is a little more focused. You can take your time, maybe have a good attitude about it. And then when you're all done, you can remove all those pragmas, just globally search and rip them out, and then enable the feature. This could work, but my favorite approach, the one I'm going to recommend, is what I call annotations first. So at the CS proj level, instead of enabling it or disabling it, you can set that value to annotations. And this is kind of an interesting phenomena or halfway step. What that does is it allows you to start going in and putting in the question marks without having to look at the warnings yet. So the concept of annotations first is to actually think about your intent. Like, what does my code mean? Rather than just trying to suppress warnings. So for example, if you have a function, a legacy function that was written like this, public static string doublet, which takes a string, and you wrote this function originally knowing that strings can be null and you're a good programmer. So you wrote it like this. If string is null or empty s, then just return the empty string. Otherwise, return this. So this is a perfectly safe, lovely function. What does it mean to look at it, though? It won't even generate a warning, right? So what does it mean if we look at it and we say, well, if I was writing this today, starting from scratch, what would I write? And what you would probably write is this: public static string, not nullable, doublet takes a nullable string. You see, this function declaration captures the actual meaning, the intent of your function, and the implementation matches that. So by adding the annotation here, now later when you turn the feature on to get the warnings are going to be smarter. You're not going to get a lot of weird false warnings because you've already done the brain work. You've gone through to think, what does my code mean? Here's another example. I've got public class person, public string name, public person parent. Oops. So probably all people have names, but we don't necessarily know a person's parent. That might be optional. So annotating this would be like this. Okay, I'm going to leave this as a strict non-nullable string, and I'll give it a default. And then I'm going to allow parent to be null, right? That's fine. So again, we're not focusing on warning suppression here. We're focusing on code literacy. And by just turning on the annotations, it lets you come at it from that perspective of let me write the code so that the code says what I mean, captures my intent. Then once you've annotated, you can go back and file by file turn on those warnings with the file level pragma and then resolve whatever warnings pop up after that. You're going to get a much more safe code base. You're going to suppress the warnings in the way they should be suppressed by having dealt with the meaning of your code first. So that's my advice. Okay, the last part of this talk, we're coming right up here on the bottom of the hour, so I don't want to take too much more time, but this is where I get to be opinionated and do a little critique here, and where William is going to be disappointed because he wants me to convert him, and this is maybe going to do the opposite, but we'll see. So as I mentioned in the beginning, people have complained about this, and I just tried to gather together what I thought were some of the salient critiques and observations about this feature. So the first one that constantly comes up is like, but they're still nullable. So like a nullable reference type like string or polygon, they're not truly nullable. You can still set them to null and your code will compile. So if you wrote this int I equals null, it ain't going to compile. It's just not legal. But if you said string s equals null, this compiles. Yes, there's a warning, but it compiles. So what I've heard people say is they're really more something like compiler assisted, probably not null reference types. That's what they should be called. Compiler assisted, probably not null reference types. So that's one thing. They're actually not, they're still nullable. One critique is that this is kind of backwards. So what do we mean? Well, C# reference types, they've always been nullable. That's the way they were from the get-go. How can you suddenly enable a feature that always existed, right? Wouldn't it be better to have called this non-nullable reference types? So imagine that instead of using the question mark, annotation mark to mark a nullable, we used an asterisk to mark a non-nullable. So string s would mean what it has always meant since the dawn of C#, could be null. But string star s2 would be this new special case, meaning, no, this one should never be null. I feel like this could have been maybe a little easier to explain and understand, but that's not what they chose. So that's just one thing they possibly considered. Another critique is that it adds a hair to C#. So one of the things I've always loved about C# is how clean and elegant it is. It doesn't contain a lot of fiddly, complicated little symbols with subtle meanings. So here's an example of two lines of C++. I think they're both legitimate lines of C++. I think they do totally different things. And it's all because of all the little fiddly characters and marks that you have, dereferencing and pointers and all this stuff, addresses that you have to pay attention to. So by adding in the question mark and exclamation point annotations, C#, in my view, just kind of starts growing some unwanted hair. It just kind of goes against the spirit of how it's been for a couple decades. This one is kind of a rough one, right? Like the whole point of this feature is to try to get people to write better code. And this critique says, but it doesn't even actually do that. So most programmers, we learn early to write defensive code. We put null guards in. Now, does this feature, null reference types, give us this false sense of security that you kind of don't need to worry about this anymore? In the same way that, modern C# programmers don't really worry about memory leaks anymore. You can still write them, but they're hard to write. So if it's doing that, then maybe it makes us worse programmers. Similarly, most of us are taught pretty early to pay attention to warnings. If we didn't learn it ourselves, we had a manager who come and spanked us and said, why did you commit code that had all those warnings? So now we have this thing that could really potentially, in certain situations, flood us with many warnings. And does it change us so that we start kind of either ignoring them or just looking for the quickest way out, the quickest way to suppress them instead of learning from them and understanding what they're telling us? So maybe it doesn't ultimately lead to better code. Here's a critique. It solves a problem that doesn't exist. So in theory, null reference exceptions are a serious problem, and they do suck when they happen, for sure. But in practice, there are many very large code bases that rarely or never experience them. And I've worked on some and written some where we had 500,000 lines of code and it's been in production for 15 years. And I bet it's never had a single null reference exception because we just wrote clean code and had good testing and good practices and just wasn't kind of an issue. So is it really necessary to add all this complexity to address something that could, in many cases, be more of a theoretical problem? It's a half measure. So it's true. Newer languages like Swift, Rust, and Kotlin, they actually have true non-nullable reference types. In Swift, for example, string and string question mark are actually different types. And only string with the question mark can be nil. String can't be nil. So when, that's true for modern languages. The reality, though, is that when C# was launched back in 2002, that was not the norm. Back then, all the revolutionary high productivity languages like Delphi, Java, and Visual Basic, they all assumed that object references could be null. They created a heck of a lot of safety and convenience, making it better than C and C++, but the concept of a null pointer was still kind of just baked in. That's what you dealt with. So is C# now just wishing to rewrite history? They want to go back in time? And if so, I would just say that the current implementation, it's kind of a half measure because, as we pointed out, they are still nullable, regardless of any annotations that you may be putting on them. And then it overloads the poor question mark symbol yet again. And I know that nullable reference types is not 100% to blame for this mess, but it doesn't help it. So, we had the ternary operator in the original C#, the null value type in C#2 uses a question mark. The null coalescing operator in C#2 uses the double question mark. The null conditional operator in C#6 uses the question mark. Nullable reference type annotation in C#8 uses it, and then the null coalescing assignment in C#8 uses it. And now in C#12, we have yet another one. I forget the name of it. I do use it. I just don't want to misstate it. So the problem here is that you really would like it in a language for one symbol to have one meaning, like plus plus or equals equals. Like those things mean one thing. They don't really change their meaning on the context. Whereas question mark now means all these different things, depending on whether there's one of them or two of them, or if it comes before or it comes after, if it's associated with a variable or a type. I mean, it's just like a lot of complexity and overload on this poor symbol. And then the last one is kind of, in some ways, the most devastating, which is that nobody understands it. Like, I've talked with lots of really smart programmers, people I respect immensely, who are like, yeah, I didn't get that. That totally blew me away. I mean, it took me an hour to try to explain this to you guys. Can you imagine if I was giving you a talk on something like value tuples or lambda expressions, and it took an hour? Now, those are also really cool, complex, powerful features, and they have subtleties. They have some gotchas. Value tuples, you got to understand equivalence. Lambdas, you have to understand scope. There are things that are tricky about them. But an hour? No. So if the purpose of this is to make the language like simpler and safer, does it instead introduce ambiguity, complexity, and possible confusion? I'm not sure. So one counter criticism is, Matthew, you're just grumpy. So I admit it. I'm old-fashioned. I wash my car by hand when I wash it, and I dry it with a chamois. I cook on a cast iron skillet. I don't do coffee flights or put truffle oil on or in anything. I'm just a bit of an, old-fashioned guy. So maybe am I just being a curmudgeon here? Is my initial resistance to this just resistance to change? It's possible. It's a fair counter criticism. Okay, so to wrap up, what should you do? I'm going to take a sip of orange juice. So one thing we can say is, it's not perfect. Wow, he's really just going to come vacuum right here. Maybe I'll just walk into an office and close the door. You guys maybe can't hear it, but I can.
No, we don't hear it at all.
It's just bothering me. All right, I'll go back under the fluorescence. All right. Um, he's running the buffer. Looks nice. Floor looks good. Okay, so the summary. Obviously, this is not perfect, and that when the C# language team dealt with this, they had to negotiate a series of compromises because they didn't have Hermione's time turner. They couldn't go back in time and just change this in C# too. But I think it is fair to say this does address something real. And when it's done right, I do think it has the ability to make for better code, especially if you focus on annotating to get the meaning right rather than, suppressing warnings. And I would say that for projects that are kind of an island, maybe the choice is yours, right? If you've got a project, it's yours, nobody else uses it. If this feature works for you, go for it. If not, I give you permission. Don't feel bad about disabling it. Okay. Anyone asks you, say Matthew said is all right. For shared projects or those in the public domain, like you work on a team that has a library that's used by other people in your company, or you publish a NuGet package, something that is used by others, you don't really have a choice. At that point, you just have to drink the Kool-Aid and enable nullable reference types because the people consuming your code are going to assume that you have annotated your library. And when this first came out, one of the most frustrating things was it was very uneven. Like even the Microsoft libraries hadn't all been annotated. And so they were difficult to work with. But now, in the last, gosh, it's almost 8 years, the ecosystem has matured. And so most public code, shareable code, has been annotated and works just fine in a nullable reference sort of context. So if your code is public, I think you have to. And for legacy projects, if you're going to convert them, just again, I'll just hammer on this little. Remember to annotate first, because the point really is to think about the meaning of your code rather than just chasing down warnings. And I do think if you come at it with that kind of perspective, it can improve your code quite a bit. Okay. So I will put up a couple QR codes that definitely don't take you to malicious sites. I totally promise. If you enjoyed this, please go to my YouTube channel at C# Artisan. I love getting new subscribers. I haven't put a lot of new content up this year. It's been a crazy year, but I will plan on getting some new content. There's like 80 videos on this kind of topic and all Azure Service Bus, all kinds of things on there. Test first development. Go check it out. C# Artisan. And of course, connect with me on LinkedIn. Love that. And we can continue the conversation. I'll also mention that the Albuquerque .NET User Group is always looking for good speakers. So if you've seen somebody or know somebody or are somebody who gives a good talk, please let me know. And let's just open it up now for a little conversation and discussion.
All right. Any questions? I know we've been asking right along as topics come up. Any questions for the C# Artisan over here?
I got
Nothing
one-
cocky.
Great name. It's a
I got
great
one
name.
question.
All right.
Matthew, can you put your slides back up? Maybe it was just a
Right.
syntax error, but I want to make sure that I understand it too. Because based on my first question, I didn't understand it.
Which slide did you want? Oh, wait. Am I not sure? I got to share. Hang
Yeah,
on.
not yet.
Sorry. My bad. Too many buttons. All right. There's that. Which slide were you thinking?
It was like int I equals s dot length.
That kind of appears a few. Let's see.
Keep going back. It's right when
Back or
you
forward?
forward, I guess, from here. Keep going. Hmm.
What is it? Some of these warnings
This
here?
one, this one. So on CS 8601, the third line, yeah,
Yes.
int j equals S1 nullable dot length.
Yeah.
Won't that return null? Doesn't the doesn't the nullable, if
Oops.
that's kind of null and you put the nullable coercion, it's nullable coercion operator, right? Won't that
Yeah.
whole line return null into int j and blow up
Yes, you're right. So then you need, I think that's a great catch.
in nullable j, right?
Yeah. So I think what we would want is int j equals s1 dot leng, something like that.
Okay, yep.
Yeah, good catch. Good catch.
All right. Anyone else been proofreading Matthew's slides and wish to suggest a syntax change?
Well, that's
Ha ha
more than
ha.
syntax. That's just a bug.
There we go. All right. Anyone else?
I'm just curious, like, let me just stop the share for just a sec. Um, if I could, Jay, like, are people surprised? Was this like, oh no, this confirmed what I always suspected, or I had no idea, or this went over my head? I'm just, because this is such an abstract and in some ways odd topic and different than some of the other ones I do, I would just like to get a little feedback about how it lands with people.
Well, you can probably tell, but I, for one, I love digging into the language like this and learning how things actually work and not guessing. But I don't believe they did this feature correctly. I'm not a fan of it. Just the way that it shows up in the project file, it just says nullable enable, but it really should be named something different. Like now I will really check your nullable types or something like that. It doesn't make sense to me. Not a fan.
So I confirmed some of what you had already kind of concluded on your own. Yeah.
Let me come in on the opposite side of that, and it's for sure acknowledging all the criticisms that you had, Matthew. This is Brett, by the way.
Yeah.
Definitely a lot of great points there, but I think for me the overall effort that Microsoft was making to force intentionality around how you handle nulls is valuable. And so I kind of like the thrust of it. I get that their hands were tied quite a bit based on that original implementation of C#. And so maybe this was the best that they could do based on all the compromises. And for sure there is some definitely some confusing elements around it. I did appreciate too you pointing out that kind of how under the covers nullable value types and nullable references are really different, right? And they're implemented different under the covers based on those annotations. That little piece of it was new to me. I hadn't dug that deep into it before, so I appreciated that aspect of it.
Well, yeah, and I think Brett is probably articulating the grown-up perspective here, the nuanced of like understanding the value and just living with some of the awkwardness. And Brett, you're not alone. I know a lot of programmers who are like, yeah, okay, yeah, it's got some issues, but but the purpose is good and it doesn't bother me, and I can get along with this. So that's sort of the range, That's again, you go into any group of C# programmers and you ask around, I think you're going to find that kind of diversity of opinion.
For sure.
Thank you. I appreciate the feedback.